Hello students. So let's talk about the thermodynamics sign convention. Sign convention given by the IUPAC, and the heat, first one is heat given to the system, then it will be positive heat to system, and heat given by the system, negative heat given by the system gives heat, then it will be negative, and heat gives towards the system, then it will be positive. Okay, so system if releases heat, then it will be negative, and system is absorbing heat, then it will be positive. Okay, so first let's talk about the cyclic process. It is made up of two or more process. It is made up of two or more process. Okay, so it is the made up of two or more process. Like which kind of process? Two types of process: open cyclic, and second one is closed cyclic. Okay, open cyclic and closed cyclic. In open cyclic there will be the initial and final. Means state or position are not same, means it is different. Like take a small example, like through the graph pressure and volume. If we starts from A point, then it will go to B point, then it will go to C point. C will be the final position and A will be the initial position. So there should be A, B, then C. There is initial and final position are not same. Okay, and in closed type, initial and final state or position are same and formed loop. And you will ask, what do you mean by loop? Now I am telling you what is loop. Take an example. First it is same, so take an example. Similar P and V. If we start from A point, then it will go to B point, then it will go to C point, then D, then back to the A. Okay, so it will go to in a cycle in a same path, initial and final, like A, B, C, D, and then again A. Similarly, it will go in a same path, this loop, A, B, C, D, then A. Okay, So let's discuss about the reversible process and irreversible process. Reversible, we can do it twice, thrice, and infinite time. And the irreversible process, we cannot do it in a twice time. But in theory wise, we understand this. Like this is the structure and this is piston. Piston putting the pressure of small sand particles and into the gas. Here is the gas and this is pressure of gas, pressure of external thing, and this is pressure of gas. If we put the sand through one by one, it take a infinite time to put the heavily pressure on this gas. Particularly if we see this structure, if we put the external pressure like any brick or you can say any the heavy object, so it will take the finite time. In the limited time it will put the more pressure on the gaseous thing. Okay, in the gaseous state it will put the more external pressure. In chemistry we will discuss about the internal gas pressure, and in physics thermodynamics we will discuss about the P external in the external pressures, and in the chemistry we discuss about the internal pressures. Okay, so basically it occurs in infinite time. Like you can see this in sand particles, there is so many light negligible heavy weight on this, so it will take more time and more energy to put the heavier pressure on this. So it take the infinite step, we cannot count how many step it will take. Hypothetically we seen that it will take the infinite steps. Similarly it takes infinite time. Obviously if it take infinite steps, then it will take also infinite time. And P external minus P gas, pressure of external pressure of gas is equal to delta P. Small change, very small change in pressure, very small, slow step. And P external is variable, it can vary. Okay, it is not the constant pressure or the constant mass of sand particle, it will vary through the time. So oppositely it occurs in finite time. In finite step it takes finite time. P external minus P gas is equal to dP, or you can say delta P. Okay, very large. Because of brick it have the constant pressure, or you can say the constant mass, or you can say constant weight. Fast step, it it is the fast process you can say. Or P external is constant, as like I said you in the previous time, brick has the constant pressure, or you can say constant mass. Okay, hopefully you get the point. Hello students, let's talk about work. Work is the mechanical way of transfer of energy. Work is equal to force into length. Like in the formal way, length is equal to displacement in the formal standard way, but in this case we took the length. And work is equal to pressure into area into length from this equation. And work is equals to force into area into delta V upon area. So area to area cutted, and work is equal to pressure external into delta V. From this equation, then work is equal to minus pressure external into delta V. So here are the four types of work. Work irreversible is equal to minus P external into delta V. Work reversible is equal to minus 2.303 nRT log V2 upon V1 isothermal case. third one is work reversible is equal to minus integration V1 to V2 and P external into delta V. Work is equal to area under the curve. Okay, so now let's talk about the isothermal irreversible work. Let's draw the figure. This is pressure external, and this one we take the volume V1 and volume Vi, initial and the final. So from here to here, at different points it will change. In the isothermal irreversible case, it means we cannot do it twice, thrice. It is only one time thing. Okay, work 1, work 2, work 3. So total work done on the system will be infinite times, or work is equal to sigma, because it's taking infinite time and it is the into delta V, or you can say similarly P external into delta V. Okay, this is the isothermal irreversible case. So now let's talk about the isothermal reversible work. So here is the graph and work done on the system. Its formula will be work is equal to integer sign Vi Vf minus P external into dV. Okay, so now minus will be this Vi Vf P external pressure external into delta V. V is volume. Okay, so we know that pressure external is equal to pressure internal into pressure internal plus minus dP. Okay, again pressure external is equal to pressure internal plus minus delta P pressure. Okay, so let's put this value on this equation 1, equation 2. Putting second equation in 1, so it will be like Vi Vf, so pressure internal plus minus delta P bracket close into dV. So let's multiply that. So P internal into dV plus minus P dV into dP. Okay, so where is where is dV or dP is a small changes, so it is negligible. Okay, so We got this equation again. VI, VF, pressure into dV. From ideal gas, equation we have PV is equal to nRT. So it will be like P is equal to N by V RT. So putting the pressure value, VI, VF nRT upon V into dV. So it will be like minus nRT, number of moles, universal gas constant, and temperature. Okay, VI, VF 1 by V into dV. Okay, so now it will be known as minus nRT ln VI, VF. Okay, we know that small equation of integration 1 by x into dx is equal to log x. From that we put this to minus nRT 2.303 log again VI, VF, so minus nRT 2.303 log final minus log initial. It will be like that, minus 2.303 into nRT log VF my VI. Okay, okay.